So why is everyone so obsessed with signals in the Angular world right now? This is because when the current signal story is completed, Angular is going to become a completely new framework. Easier to use, with a better developer experience, faster. Signals are going to be a massive leap forward for Angular. So in this video I'm going to do something a little bit different. Let me take you on a time travel to the future of Angular. Let's pretend that we already have signal-based change detection and that the signal story is completed. What will Angular look like then? I'm going to give you my take on what signal-based change detection is going to look like, what the developer experience is going to look like. I'm going to tell you where I think things are headed and why, so that you can already start wrapping your head around this new way of building applications in Angular using signals. So without further ado, join me on this time travel into the future of Angular. Welcome back to the Angular University channel. I'm Vasco. So the signal revolution in Angular is coming. What will Angular look like? And most of all, what will it not look like? What do we know about the future of Angular? That's the topic of this video. I'm going to piece together all the information that we have in podcasts, RFCs, interviews, GitHub issues, etc. Bring together all sources of information and try to give you a complete picture of what you can expect in the near future of Angular. So what will the code of an Angular application look like, and how will signal change detection work? Well, usually if you are writing your application using signals, all the data of your application will be wrapped in a signal primitive. So you will no longer have member variables in your components, typically that are primitive types themselves, that are object types, arrays, etc. Instead, all your data member variables, such as here the course member variable, will be signals. You can see that this is a signal of type course, meaning that it's a signal whose emitted values are instances of course objects. Alright, now imagine that you would like to give access to this course object in multiple places of your application. In this case, I'm wrapping this here in a service. You could do so by injecting the service wherever you need it using the Angular inject function, and from there you can access it here using this syntax. You access the signal and then you can access here the different properties that you need in your local template. You can see that if you want to do something in your application in response to a new value of the signal getting emitted, you can do so using here the effect signal primitive. Notice that this is just an example of a possible pattern to build your application. You don't have to wrap every single data in your application in a service and inject it. If you only use the data locally, then you can have here the signal directly at the level of the component. This is just a common pattern that you might want to be aware of in case that you want to share the same data via signals across multiple parts of your application. In our case here, we are also injecting the same service here in our application component, and we are using that same service here in a different part of our application. So we are using it on two places, on our application component and on our course card component. Notice that the syntax is always the same. We invoke the signal and therefore we retrieve its latest emitted value, and then we access the properties of the object that we want in case that the signal is emitting an object, like here in the case of the course signal. If it's a numeric property, then we can access it like this directly, or any other primitive value. So signals can be made out of objects, primitive values like strings, booleans, numbers, arrays, or any combination of all of those. Let's now go beyond the basics and talk about how Angular signal-based change detection is going to look like. This is one of the big questions that we have. So if we check here the signal-based components RFC, we're going to see that there will be sort of a signals true flag that we are going to be able to add here in our components next to the standalone flag, and this turns our component into a signal-based component. This means that this component, unlike the rest of the application, is going to be based on signal-based change detection. What does this mean? It simply means that the component instance is going to be marked as dirty if one of the signals consumed by the template emits a new value. If none of the signals consumed by the template emit a new value, then the component instance will not be considered dirty. Notice that this property is not transitive, so marking one signal-based component as dirty in the leaf of a component tree is not going to automatically mark all the parent components as dirty as well. Signal-based change detection is completely isolated from the rest of the component tree. This is really to mark component instances dirty or not, one by one, based on the template consumption of the signals at hand. Now, what if we have an application that uses signal change detection everywhere? Well, we can safely expect to be able to turn it on at only one place at the level of the whole application instead of having to apply signals through everywhere. We can expect that API to be available sometime in the future. Now, how well will signal-based change detection work compared to default and on-push change detection? It should be a major step forward. Signal-based change detection in Angular should bring you all the benefits of on-push change detection without any of the drawbacks. So it's kind of a mix of a very easy to use user experience or developer experience, like in the case of default change detection, with the high levels of performance of on-push. Signal-based change detection is not going to impose on you or your application any special constraints other than having to use the signal-based API to wrap your data. So the way that it works is completely different than default change detection or on-push. With signal-based change detection, instead of the Angular framework having to try to guess what has changed in the user interface in order to be able to update it, the Signal API is going to inform Angular exactly what has changed. So Angular now knows via signals what has changed exactly and knows exactly what components need to be re-rendered, and it can update those in an optimal way. So the whole notion of change detection is kind of out of the window and it doesn't apply anymore. There is no such thing anymore as having to detect the changes in the application. With signals, Angular knows exactly already by default and without having to do anything special or complicated what has changed. So you could even claim that signal-based change detection is not actually change detection, it's just a new reactive system for updating the user interface in response to data changes that does not involve having to detect what has changed. Now let's talk about state management with signals. This is an important topic and I'm going to present you the main problem that we need to consider that relates to the use of the signal primitive when emitting values that are deeply nested values. So here the course object could be a deeply nested value. This could also be the centralized state of your whole application if you are using a centralized store pattern. Imagine that the value that you are emitting in your signal is a deeply nested object that can have arrays as properties and other nested objects with properties that could be arrays or other nested objects, etc. A deeply nested object. Well, if you notice here the way that our application is currently built, whenever we emit a new value for the course signal, then all the consumers are always going to be updated because each signal value is a new instance of an object. Now, this means that components such as, for example, the course card component will get updated and marked as dirty and therefore re-rendered if a new value of course gets emitted independently of the actual properties having changed or not. So imagine that here we have this signal service and somebody calls here update course title and we emit a new value of this signal that has all the properties identical accept here the new title. Well, this change is going to get propagated here to the course card that needs to be repainted, and here to the application component that needs to be re-rendered, which is exactly what we want. We want that the components that depend on the signal to be re-rendered. But now imagine a situation where we emit a new value, and the only difference in the course object towards the previous value of the signal is the sequential number field that has been incremented, for example, or modified. The sequential number, on the other hand, is not being used either by the course card or by the application component. So ideally, in this situation, we would prefer that neither of these components actually gets notified that they need to be re-rendered. They don't need to be re-rendered because the data that they actually consumed has not changed. So how can we solve this problem, and where do state management solutions come in, and what do other frameworks do regarding this situation? Well, one potential solution for this problem would be, instead of using a deeply nested object, to turn each and every property of the deeply nested course object into a signal itself. So each property itself would become a signal. Then in that case, we could become very fine-grained about this and update only the parts of the application that need this particular property. Of course, it would be cumbersome to do that manually and declare every single property as a signal, so we could potentially conceive that the Angular framework could maybe add here a create store new primitive in order to solve this problem and automatically create this deeply nested store object where every property is a signal. This would be in line with what other frameworks do. So let's discuss if there are reasons to believe that this would happen in Angular. First, let's have a look here at how Qwik does it. Qwik, if you are not familiar with it, is a framework created by Miško Avery, and of course there is a whole team as well behind it. Miško Avery is the original creator of the Angular framework itself, and here they have this concept of use store. Notice what it says here: reactivity happens even for nested objects and arrays. So to use store, we pass in here an initial object, and Qwik is going to internally turn every property into a signal. If you check here how this is used, you can see that here our signal, that our store that contains here a count property, this becomes a signal, so we can access the signal property here via the .count notation. So notice that it looks really like we are accessing a plain JavaScript object. Actually, internally we are using proxies, and we are accessing here a count signal, and we are retrieving the latest value of the count signal. And notice that Qwik has even taken the use of proxies to a whole new level. So we are calling here, for example, counter.count++. We can modify the properties inside our store just like if they were primitive values. So under the hood, what is happening here is that we are using a proxy that is emitting a new value for the count signal. So we are not actually modifying here a primitive value. This is all working by proxies. So the question is, maybe we could conceivably see something like use store here in the Angular frameworks, like this hypothetical create store construct. Will this be in an hypothetical future of Angular? Well, based here on what we can tell from the completed signals for Angular reactivity RFC, that should not in principle be the case, at least not at the level of the framework. So if you check here for state management, it says here, what about state management with signals? They are a great primitive, and state management solutions will emerge. Dedicated state management libraries can address many development concerns, such as, for example, composing stores, etc. And it says here explicitly, we have no plans to develop a first-party state management solution in Angular itself. The broader Angular community possesses a wealth of knowledge and experience in this area. Some major state management libraries have already started to explore incorporating signals. NGRX Signal Store, signals in NGXX, RX Angular, etc. So as you can see, according to the Angular team itself in the RFC, they have no plans to add this construct at the level of the framework, and the decision is that this is going to be left to libraries to provide this type of constructs. You already have available NGRX signal store if you want to play around with it, that allows you to do just that. So here with NGRX signal store, you define here an initial state, you pass it to signal store, and signal store is going to turn each of the properties of this deeply nested object into signals themselves in a recursive way, just like I have explained, in a very similar way to what Qwik does here. However, there are no notions here of proxies. So if we search here on the Signal API's RFC for proxy, we are going to get here some hints for the future. So the Angular team wanted to focus on the smallest primitives possible. So that means that their focus was on the signal primitive here and not on the construction of store constructs. So they decided not to proxy access to primitive values to avoid having too much magic and weird behavior in the framework. So regarding the potential use of proxies in the future that encapsulate bigger nested JavaScript objects, so this is the problem that I was explaining earlier. It says here we might explore proxy usage here and there and expect the community-driven proxy-based state management solutions will be available in the future. So as we can see, we have a very clear indication that in the future of Angular there will be no official framework state management solution. There will be no create store construct or use store like in the case of Qwik. This is going to be handled at the level of libraries such as NGRX. So I'm going to do a whole new video about it. You might want to subscribe to the channel if you haven't done already. Leave me a like here as well, and make sure that you don't miss the upcoming video on NGRX Signal Store. Now, what other things can we talk about the future of Angular? Let's talk about interoperability between Zone.js and Signals. So based on that, based on the RFC of Signal interoperability, we know that there is going to be full interoperability with zone level components and also full interoperability with RxJS. So it's not like you are going to have to be forced to completely rewrite your applications overnight in order to be able to continue to upgrade your Angular applications. Instead, you're going to have a smooth upgrade path. You're going to have full interoperability with RxJS, and zone components and signal components and on-push components are all going to be able to coexist without any problem in the same Angular application. Full backwards compatibility is ensured by the Angular team. Now, to conclude this video, a couple of very common questions about the future of Angular and Signals. Will the support for zone components be dropped sometime in the future, and will there be some automated migration that will allow us to migrate to Signals? Well, we have some clarity there as well. Here is a response from Alex Rickerbuck from the Angular team. So as you can see, when asked about these two same questions, we have here the answer that at Google they have thousands of Angular applications, and they are many of them built on Zone.js, and if the Angular team would want to drop support for Zone.js, they would be responsible themselves for migrating every single one of those applications. So unless something major changes, they would not even attempt it. So the idea that zone-based components are not going to be supported in the future, it's not true. Zone components are supported for the foreseeable future, and unless that there is a practical way of migrating the applications that does not involve a tremendous amount of manual work, zone-based components will essentially never be dropped from the framework in the upcoming years. This would ever happen, it would be very far off into the future. Right now, based on what we know today, it sounds highly unlikely. Now, what about automated migration to Signals? We have here the following. We We are pretty sure that we can't automate the whole process, but we are going to be looking to building tooling for assisted migrations. So when it comes to migrations with the Angular CLI, we could expect something similar to the migration to standalone components, where we have a migration with several steps, and those steps, if we go through them, although they don't migrate the application completely, they get pretty close and they simplify a lot the work of migrating. So this is the type of migrations that we can expect in the future. For signals, we can expect some sort of automation at the level of the Angular CLI, but we will never get full automated application upgrade via the Angular CLI without us having to do any refactoring. There will be some refactoring involved for sure. So let's summarize our main conclusions about what we know of the future of Angular. The Signals API is completed. It will not include a state management solution, so we will, if we need to have to use something like NGRX Signal Store. I think that this is great to know for Angular team leads and decision makers. We have a pretty good idea of what's coming. We are going to have partial upgrade migrations. We won't have to do all the work ourselves, but it won't be a fully automated process either. So this means that now is the best time possible to start learning about Signals and the Signals API, start learning about NGRX Signal Store. So when Signal components drop by, we are going to be able to be in a very good position to migrate if needed and keep our applications maintainable over time with the latest best practices. On the other hand, if you have a zone-based migration, you can rest assured that you will have full backwards compatibility for a very long time. There is currently no plans whatsoever of dropping support for zone-based components from the framework. So I hope that this video helped. Please leave me a like here and comment what other content would you like to see here in the Angular University. If you are looking to learn about Angular, check out my courses here at the Angular University. They are upgraded to the latest Angular 17. Check out here the subscriptions. These are the prices and you get access to the whole content of the website. If you don't want a paid subscription, go ahead and try out the free lessons. Every lesson here that doesn't have the P for Pro is free, so we are going to find about 25% of the lessons on the website are free. You can watch them even without providing your email, so we can watch them for free without having to provide any of your details. You can watch the whole Angular for Beginners course for free. It's over 2.5 hours completely for free without having to sign in. So I hope that you have enjoyed this video. Thank you so much for watching, everyone, and I will see you next time. Cheers, everyone.